All right, good morning, or maybe good afternoon, depending on when you're watching this. We are going to go ahead and take a look today at the next section after our quiz titled Direct Variations. Now, according to Garrett Bachman, or some of you may call him Boogie, all right, he gave us some information this morning that I think some of you are going to have knowledge of leading into direct variations. So, this is the first time you've ever seen something like this, probably. So, I'm going to ask that you go ahead and get your notebooks out. Along with your notebooks, you're going to want to go ahead and make sure that you pause your video as you're taking notes. Maybe you rewind to look back through something. We'll go ahead and have a slide I'll add to it. So that's definitely something you're going to want to put into your notes, and you'll kind of see that as we go. Some of the must-haves for what's called a direct variation. All right, so today, if you kind of just take a look at this, here's kind of what we're going to be seeing. Let's get that out of the way. All right, so what is a direct variation? Up here, that's going to be number one. Then we're going to look at some slopes of direct variations. We'll just quickly graph them. And then can we write and solve some direct variations? But first, before any of that stuff, we're going to have to figure out what it is. Now, I don't think you guys need to worry about this first one, but I'd like you at this point to go ahead and try number 2 in your notes. I'm going to go ahead and complete it. So before you finish, I want you to pause your video and then try to go ahead and complete number 2. When you finish completing number 2, turn your video back on and we'll see if you come up with the correct answer. All right, so here we go. I think the first thing we need to do in this problem as we look at it, in 2005, there were 12,458 fish in Houndstooth Lake. That right there should be an ordered pair. So 2005, gonna need a little more room here, comma 12,458. Now, after years of drought, there are only 968 fish remaining. Well, there we go. In 2010, we are unfortunately down to 968 fish. So the question here is, what's the rate of change? Now, yesterday you had a question on your quiz. Your quizzes are graded, by the way, so if you want to go ahead and check online, I will give those to you the next time I see you, which will be tomorrow. But on that quiz, there was a question, number 6, about the short tons of coal that is mined in the United States. A lot of you guys made a mistake here when you were talking about trying to show a decrease in that amount. If you'll write your ordered pairs, I think you're going to find that we should end up with a negative in this situation, but more importantly, where is that negative going to be? So as we go ahead and solve this, you can think y2 minus y1, so in this case 968 minus 12,458, all divided by 2010 minus 2005. And give me 1 second because I don't have a calculator in my hands. If we do 968 minus 12,458, we end up with a negative 11,490 every 5 years. It's really important here that you remember that your negative in this situation really should be on the number of fish and not on the number of years. It would not make sense to say that we had a positive 11,490 fish in negative 5 years. That just doesn't seem right. So make sure when you're setting this up that you understand the scenario that we're having. So a lot of us made a mistake in relation to number 6 on our quiz. That's why we're looking at this one now. If you still have issues, we can talk about that tomorrow. All right, so today, can we write and graph direct variations? That's going to be number 1. Are we able to do this? And then secondly, can we solve some problems that involve the idea of a direct variation? So number 1, what is a direct variation? Well, let me give you this example. Right here we have not Mexican, it's a Spanish dish, rice-based, called paella. And in this dish, the following scenario has to hold true. Every cup of rice will make 5 servings. Okay. So if that's true, the following relationships are down here. So right here in this scenario, if you got 1 cup of rice, you got 5 people that can be fed. 2 cups of rice, 10 people. 3 cups, 15 people. 4 cups, 20. Hopefully, you're recognizing that in every one of these situations, there's something that holds true. if we do 5 divided by 1, or 10 divided by 2, 15 divided by 3, or 20 divided by 4, we end up with the exact same answer, and I'm hoping you're saying that answer is 5. All right. Direct variations will always hold this relationship. Each one of these scenarios, every relational pair gives you that same answer every single time. Okay? Algebraically, we often use the phrase that it varies directly. Now, if you continue to think about this process, obviously moving to the right, we could continue those paths, right? The next one would be 5 and 25, then 6 and 30, so on and so forth. More important than that, though, I want you to think for a second, what does the next ordered pair to the left or before this path have to be? Okay, so take a second, look at that path. Hopefully at this point you're recognizing something, that this ordered pair has to be 0, 0. That is a number one requirement of a direct variation. Okay, so I'm going to open up a new slide here, and I want you to put this down in your notes. Every direct variation must contain the following statements. Number one, it must go through the origin. That is number one. Number two, if you think about all those ordered pairs, maybe we'll do a little split screen here. If you think about these ordered pairs on the left-hand side, okay, all ordered pairs, okay, must divide to the same, I can't spell, same, where's my E? The same number. All right, and if we look over here at all the highlighted pieces over here, all of those relationships must remain the same. Y divided by X, whatever that equals, okay? Whatever that is, okay? Those always gotta be the same. We're gonna add one more here in a second. Okay, before we do that though, we're gonna come back over here to this first screen. All right, sorry, jumping around on you a little bit. Okay, but I thought maybe I'd just show you this goofy looking picture here. This is an example of that paella dish that I was talking about. So you can see here, extremely large. I think this is probably a seafood variety of that paella, but you can see that it's mainly comprised of rice. And in this case, it looks like they got maybe some clams or some mussels, some shrimp in there. So there's an example, but let's take down here a little bit further. So you can see here that a direct variation is a special linear relationship, right? So we know it's a straight line, okay? But it can be written in this form here, and that's the next thing that we're going to add on our list. Okay, so if we go back to this split screen for a second, the next thing we're going to add to that list is that each direct variation equation, oops, I lost it over here. Let's bring this back. Sorry, there you go. Sorry about that. Every one of these can be written in this form. Y equals K times X. And if you read there at the bottom, it says that this K value right here, it's going to seem a little strange, but it is known as our constant of variation. Now, if we go back to this goofy picture over here and we slide back to the top, you can see that right here, they tell us that this equation can be represented by y equals 5x. And that 5, if you notice, if you look at both screens, that 5 is in place of our k. So in this particular case, k, or our constant, is equal to 5. All of our divisions over here are also equal to 5. So that means that if we take this question mark off, what are we really placing here? We're placing the k value, that constant of variation. All right, this guy right here is that same k value. Okay, so what do we really have? A constant of variation, if you haven't picked up yet, really is the same as 5 letters, starts with an S. Hopefully you're thinking slope. All right, it's really one and the same. The only difference is we're guaranteed at this point that we're going to pass through the origin, where other linear functions don't have to necessarily pass through the origin. All right, so quickly, we're going to take a look at just 4 equations, and I want you to, if you have to stop and pause, you can do that for sure, but I want you to ask yourself, is this a direct variation? So in your mind, here's what I'm thinking. Can I write this in the form y equals k times x? I think the answer to that question is yes. And what is my constant? Well, what's in place of that k? It's a 3. All right, so we're going to look at 3 more. So here's the next one. Take a second. If you want to pause your video, you can. All right, right now I'm thinking, can I move this to the other side? Absolutely. So I'd get something that looks like y equals negative 3x plus 8, 100% linear function. But in this case, I'm going to say no, that it is not a direct variation. There is no constant, and it's the reason right here, that 8. All right, can't have that 8 on there. Not going to go through the origin. Number 3, okay, if you want to pause again, you can do that. Think about moving this to the other side. 3y would be equal to 4x. If I divided both sides by 3, I would get y equals 4/3 x. Direct variation, absolutely. Okay, no y-intercept, going to go through the origin, constant, 4/3. Last one. Look at this right now. I'm going to say no for this reason right here. Okay, could I divide by 3? Sure, I could divide it all by 3. But when I do that, I end up with 4/3 of x plus 1/3. Not going to go through the origin. Not a direct variation. Will not have a constant. Okay, so just thinking about how it looks in an equation form. Now, we already kind of took care of this. All direct variations, if you look at these 2 pictures, have to go through the origin. Obviously, k greater than 0. You can see there, it says right there, my slope. So k and slope, one and the same. It's positive. And in this one over here, obviously being less than 0, it's a negative. So if I look at this picture here, if I'm asked to, number 1, name the constant of variation, I can find it from this picture right here. I would say that my k value is equal to 2. And then they ask me, secondly, can I find the slope? Well, that's kind of a trick because honestly, if we come over here, our slope is up 2 and to the right 1. So we could say that our slope, or our m value, is equal to 2/1. But just like we said before, all of these are the same. So my slope is 2, my constant is 2. Remember, the only thing that makes it a direct variation, obviously besides being a straight line, is that piece right there. It has to go through the origin. All right, real fast, do you think it's A, B, C, or D? I'll give you a second to try that one. If you pause while you're thinking about it, come back. Hopefully you're recognizing quickly. It has to be choice D. Okay, there it is. Call it your K if you'd like. Rise 3, 1 to the left, 3/-1. We see these values are the same. Okay, so graphically speaking, pretty straightforward. So now what does it look like as a graph? Well, remember, -3/2, sorry, we don't want to put that there, is in the form y equals k times x. So this value here and that value there are the same. No y-intercept here, which means, graphically speaking, has to go through the origin. Now, how do I handle k? Well, I handle k the same way I handle a slope. So if you think about this negative, so if we take this negative out of the middle, okay, If we give it to the value on the top, remember you've got to place it on the top or the bottom. If we give it to the top, we're down 1, 2, 3, and to the right 2. Or if we give that negative to the bottom, then if we go back to our red dot, we are now going up 1, 2, 3, and to the left 2. Either way, those points are all part of the same straight line path. Okay, direct variation. It's linear, has to go through the origin, and your k value and your slope are actually one and the same. So quickly, which one of these 4 do you think is the right answer? Okay, we can see right here that says k is 2, so our slope is 2. Can't be A, that's negative. Can't be D, that's negative. It's got to be C or B. It's got to be one of them. But we see right here, we are up 2 and over 1. But down here, we are up 1 and over 2. That's 1/2. So it's not C, has to be B. All right, last one. Once we finish this one, we're going to you have a worksheet that goes along with today. So you can go back, you can watch the video to help you through any of the sections on the homework, or if you've taken pretty decent notes, then you can try to complete your worksheet. But once you finish this, you'll know at that point it's time for you to come up and ask for a worksheet. All right, so here we go. Last one. There's the phrase right there. It varies directly. Okay, so we are asked to find the following statement. You know y is equal to 3 when x is equal to 9. And so the question is, can you figure out what y is when x is equal to 21? All right, now I'm going to shrink this screen down, hopefully enough that you can see all of this at the same time. So there's really 2 options to how to solve a problem like this. All right, up here at the beginning, method number 1. You can figure out what k is. Remember, k is equal to y divided by x. Once you figure out that k, this answer here, put it right in there for k. And then you can use this blue statement up here to help you figure out what y is. That's option number 1. Or down here at the bottom, option number 2, make a proportion. Okay, if you make a proportion, then you're going to use the statement. We'll highlight it so you can see it here. We're going to use that statement right there, y divided by x. Okay, so I'm going to ask you again, and hopefully you're doing this. I want you to pause your video right now. Take a second, see if you can't figure out. Remember, we're looking for the value of y. All right, so we're back. Hopefully you paused. Hopefully you have an answer, and we're waiting to see if your answer matches. Me personally, I like method number 2. I like the idea of a proportion. So if we come down here to the bottom, we know the following statement. Y divided by x. 3 divided by 9 must be the same as y divided by 21. If I cross multiply and divide this, I should find out that y is equal to 7. Okay? Other way I can do that. Method number 1 up here at the top. Still going to use the fact that y over x is equal to k. So I know 3 over 9, which means I know that k is 1/3. If I use my equation, I will write y is equal to k, which is 1/3. I know that x is 21. So ask yourself, what is 1/3 of 21? And you would say that y is 7. You can see both of those statements give you an answer of y equals 7. All right, so real fast, in recap, if we come all the way, where is it? All the way back here. Those are all the things that are true about a direct variation. Got to go through the origin. All your ordered pairs must line up to be the same divisibly. Y divided by x, which is equal to the statement of k. K is called our constant of variation, and that is truly the same thing as our slope. All right, so that ends our video for today. At this point, go ahead and get up or raise your hand and ask for a copy of the worksheet.